This conference will now be recorded.
Hey, David, I'm just letting you know I can't hear you. I think you're muted.
Sorry.
There you go.
Sorry. I will speak about today's agenda. We will start from opening remarks. After opening remarks, then Wagner will present presentation to tips from tech support. And after that, we will have a break, coffee break, and after coffee break, we'll have a second presentation, surface modeling in SolidWorks. We'll present Samuel Sargsyan. Presentation will be in Armenian. And after presentation, we will have we will review competition results and winner award. Also answers, question answers, and we'll select next meeting date. So I will start from opening remarks. We have, I want to update SWUGN news. I want to note that we have shut out in SWUG leaders meeting, and I told about our first awesome meeting. The second news is that now we have a SolidWorks user group network map, and our group also in this map. And finally, about one event I want to note. It's SWUGN 6. SWUGN 6, it's SolidWorks' largest user group meeting ever. In this year, it will be 24 hours, and will start in August 21 and will end on August 22. And now I want to introduce to all Dan Wagner. Dan Wagner is Dassault Systems, working in Dassault Systems. He is SWUGN manager, and he will present SolidWorks tips and tricks from technical support. Then just a minute, I will give you. You can share your screen.
Fantastic. There we go. All right. Okay, thanks, David. Quick, and David, by the way, this is awesome. This this hybrid format, right? I know you have people there live in the room, and you have myself and a few other people joining remotely. This is awesome. This is like, I think this is actually the future of SWUGN, of the user group network, because as we all know, in the last 2 years, really in 2020 and 2021, we had to be mostly virtual, almost entirely virtual. And we're finally getting to the point where we can return to physical meetings. And I actually see this as kind of the future of being able to have people there in person, but also live stream the meeting. So really great, and I think this is fantastic. It's great to actually see people there in the room. That's awesome. So thanks for setting this up, David. And David did mention a moment ago. Go ahead, David. I'm sorry.
Sorry, without masks.
Without masks, right? Yeah, it's great, and it's refreshing to be back to normal. You know, it's fantastic. So David mentioned a moment ago the SWUGN map, and actually you can see this map anytime you want at solidworks.com/SWUGN map. That's a live URL. And yeah, we see the Armenia user group on here. We see all of our user groups across the world on here. This is just a quick screen grab of it. One of the nice things about this map is it links to all of these groups' meetup pages. So as you click on one of the groups, you should be able to pull up that group's meetup page and get more information about it. So check that out. Okay, so this presentation, Tales from Tech Support, and I used to call it Tips from Tech Support, and it kind of turned more into Tales because it's more of a story. You know, every case here is more of a story of what happened with that case. Prior to my role here, prior to being the user group leader here at SolidWorks, at Dassault Systems SolidWorks, I spent a lot of years working in tech support at a SolidWorks reseller. So I'm assuming everybody there in the room is a SolidWorks user in one form or another, and you probably had to purchase that license of SolidWorks from somebody, from a reseller, from a third party, because we actually rely on those resellers for local support. So I worked for one of those resellers here in the States for many years. I went to Temple University in Philadelphia, Pennsylvania, College of Engineering, and I spent about 12 years right out of Temple at a reseller. It was actually a small reseller that was acquired by another reseller that was then acquired by another reseller. So by the time I left that reseller, there was over 300 employees, many of which were in technical support. So I spent a lot of years working at the reseller, getting my CSWE, Certified SolidWorks Expert, thousands of support cases, and hundreds of SolidWorks classes taught. So the bulk of my time there at the reseller was doing technical support and teaching SolidWorks classes. So maybe some of the folks there in the room have taken SolidWorks Essentials or SolidWorks Drawings or SolidWorks Surface Modeling or weldments. One of these classes, I taught all of those classes, and I really enjoyed teaching those over the years. And then somewhere along the way, around 2013, I started managing technical support, so helping others improve their skills. I was a regular presenter at my local user group, so there's a user group local to me here in Pennsylvania, and I was a regular presenter there. And I also presented at a few SolidWorks World conferences. So if you're familiar with SolidWorks World, which became 3D Experience World, I also presented at those different presentations. Aside from SolidWorks, aside from your core SolidWorks product, I also specialized in Composer, SolidWorks Inspection, and SolidWorks PDM. So if you know any of those products, if you've ever used Composer, Inspection, or PDM, they're all very particular products. They're not solid modeling, they're very specialized. I spent some time with those as well, and I'd love, David, I'd love to do a presentation on one of those in the future. Maybe if anybody ever wanted to see something on one of those products, we could certainly do that as well. And I want to say, by the way, I don't do tech support anymore, right? I now manage the user groups, so I don't have a connection to tech support cases. So if you run across anything interesting, if you encounter a interesting scenario with one of your support cases, please send it to me. Please loop me in and tell me the story, and I'd love to include it in this presentation in the future, because this presentation, I built it over the years, over a few years, but I don't get those cases anymore. So it might become stagnant at some point, right? So if you find something interesting, please feel free to send it to me. Okay, so we're gonna do this in almost like a question and answer format. This is case number 1, and that's how we're gonna approach this presentation. We're gonna approach it just case by case. And the very first case, we'll start with a simulation case. So if you're not familiar with simulation, it's FEA, finite element analysis. In SolidWorks, you can put a stress on something, put a fixture on that model, and then SolidWorks simulation will tell you how that model will perform or how it will deform under stress. So this was an interesting question from a customer, and that's again how we'll approach this example. If I have a brand new study here, I have just a plain old basic sample part, right? There's nothing too special to this part. But what simulation allows you to do is if I pick this fixture and say we're going to select some fixed geometry, you're basically making an assumption that this face here, this face is fixed, whether it's welded or glued or screwed down, whatever the case is, you're making an assumption that that face is fixed and it cannot move. All right, so that's our first rule. We'll set that up. Our second rule is we're going to apply a load. So I pick external loads, we'll pick a force, and I'm going to apply a force to that face. And this little face up top is actually, it's still in line with the rest of this part. But what I did is I split this face at the top so I'd have a smaller area, smaller spot to apply that force to. And maybe we'll just make this really easy, right? We'll just do this little tiny face is getting 50 pounds of force applied to it. So we know what our fixture is, we know what our force is. Simulation also needs to know what the material is. What is this model made of? So in this case, I'll pick this model and we'll apply edit material. We can even see favorites here. So maybe this is made of a 1060 alloy or a brass or something really hard or something really soft, maybe depending on the metal that we pick. And even if you dive into the library here, if you haven't seen this before, the SolidWorks material library is pretty extensive. There's a lot of material choices. So again, we'll just go with a standard 1060 alloy aluminum here, and we'll apply that. So simulation has pretty much everything it needs to run this model. So the question from the customer is, once we run this study, and this will run quick because it's a pretty simple part here, and if we animate this displacement here, let's see if I can get this to show. There we go. Animate. The question from the customer is, all right, I see how much that's moving. I can see how much that's moving from the 50 pounds of force applied to it. And the original question is, if I return back to my study, if I return back to my tree here, and we edit that force and I maybe double it or triple it, if I now push it up to 100 pounds, I just double the force that we're putting on that face, and then we rerun this study, which again will happen pretty quick here, and then we'll animate. The question is, why does it still look the same? I just put twice the force on that face. I just applied twice the amount of force onto that face. So why does it still look like it's deforming basically the same amount? And the answer in this case is something called, and I'll zoom in so we can see it here, deformation scale. And deformation scale is SolidWorks basically scaling up the motion so you can see it, because in a lot of cases, deformation is so small, it's so tiny that it would be very difficult to even see it moving. So in this case, SolidWorks is scaling it up by almost 5 times so we can see it on screen. And what we didn't notice is this number was actually changing between those two values. So here it's scaling it up by about 4.7, right? So I'll hit green check and confirm that. And if we go back to that original force here and we change this back to 50, I rerun this study again, that happens very quick. If it's a simple study, that'll run very fast. We go back to displacement. Now notice that displacement is only about, is a lot more actually, it's 9.4. So it's having to scale up that motion a whole lot more to show you that same movement. And the point of that movement is really just for you to say, yeah, that's deforming as I would expect. It's almost validation for you, letting you know that you applied your forces correctly, you fixed the model in the right spot, and everything looks correct to you there. You do have the option in chart options, instead of doing instead of doing a exaggerated scale, you can do what's called, I'll zoom in so we can see it here, you can do what's called a true scale or a user-defined scale. So you can adjust this if you want. You can change how this reacts. So if I did true scale in this case, and then we animated that displacement, you can see the movement is actually really small. That movement from 50 pounds or 100 pounds is actually really small, but we want to see this thing move on screen, and that's why SOLIDWORKS will turn up that deformation scale. So the answer for this customer, why do my deformation results look the same regardless of applied stress? And that was the call into tech support for me at that time, is a customer's calling in and saying, I'm changing my stress, but my model looks the same. What's going on? Why is it not updating? And in this case, we had to discuss deformation scale. The other interesting thing about this case was the customer was actually using Simulation Express. And this is something important for everybody there to know. If you ever want to just try simulation or try one of these other tools, if you go to Tools, Express Products, if it's right under this Tools menu at the top, I'll zoom back out so we can see that. Tools, Express Products, Simulation Express. Everybody has that, regardless of what license of SOLIDWORKS you have. That's in every single license, with a caveat that it only does one part at a time, and you can't change that deformation scale. You don't have all the control that you would have if you were using, for example, what I am is full-blown SOLIDWORKS simulation, which is a separate purchase, or a separate add-in, I should say, from the software itself. If you have SOLIDWORKS Premium, if anybody there in the audience has SOLIDWORKS Premium, you actually have SOLIDWORKS simulation. You have the first level of SOLIDWORKS simulation built in that you can test with. All right, so that was question one. Question one's kind of in depth, right? We're jumping right out of the gate, starting with a simulation question, but still very interesting. And the whole conversation around deformation scale is really interesting and definitely something to look into. Question number two, we're switching from simulation to routing, to assembly wire routing. We're gonna jump all over the place with this presentation, and that's actually one of the things I like about it. And it's very similar to tech support. You never know what kind of phone call you're gonna pick up, you're gonna get in tech support, and it could jump right from simulation to routing. So in this case, the customer was asking, how do we create a standard route that we can reuse again and again and revision manage it in PDM? And this is really interesting because routing is all about automation. Routing is all about making things happen quickly. So I'll jump back to SOLIDWORKS here. We can close this simulation example. We don't need that open anymore. And I have this electrical enclosure opened. This is a pretty simple electrical box, one board with a sheet metal box around it. And this question from a customer was, we create very similar routes over and over again. Maybe you're a company that manufactures these boards, and these boards stack on top of each other, one after another, and you have to make jumper cables that go from one board to the next one. And that cable is always the same. In fact, you have 100 of them on your shelf, right? It's always the same cable. So you shouldn't have to model it over and over again or create it with routing. But what does routing do even just by itself, right? Let's look at a quick example. I'll go to my design library here. We'll go to routing, we'll go to electrical routing. And in electrical routing, if I start with one of these components, I see this library of existing components in here. And the component we're looking for is this Rj45 connector, which is essentially like an Ethernet connector, right? If you've ever used an Ethernet cable. So if I drag and drop this Ethernet cable connector into my assembly, and I stop right there on my screen, SOLIDWORKS will recognize that that is a routing component, and it will actually start a new route. It began a new route that quickly, just by me opening and dragging in a routing part. So I'll hit green check to confirm that. That looks good. I'm just kind of starting with this example route here. The next thing it does is it will allow me to bring in another component. So let's bring in another Rj45 connector. I'll just kind of drop that probably right down here on screen. We'll drop it right here in space. That looks pretty good. And out of each cable, it's applying what's called a stub. There's a little cable stub that's kind of sticking out of each connector there, I should say, not cable. So with each connector, I can auto route from one stub to the other, and routing will handle that for you. Routing will handle that that little connection. How would you do that normally? You would do a sweep, right? You would sweep a circular path and connect those two components. So if I hit green check and we exit that sketch and exit the route, I now have a really simple wire that goes from that Rj45 connector to the other. But if I'm a company, if I'm doing this over and over again, I don't want to have to recreate that route again and again and again. So here's two methods you can use to do this, which I found really interesting. In electrical routing here, the first one is something called standard cables. Standard cables is the ability to have a library of cables that you use over and over again. So if I choose standard cables here, I have one called test. It's just a test cable that I pre-created here. And once I choose test cable, and if I hit insert cable, it kind of does what we saw a moment ago. It will ask me to drop these components. Here's the first one. I'll roll around here. Here's my second one. And then as soon as those two are connected, it begins a auto route function. And I actually have a standard length set on this cable, so it's trying to route all the way around to hold on to that standard length. And that was another question from the customer here. I'll jump back out. And they wanted to create this this route again and again and revision manage it in PDM. So keep that last bit in mind, revision manage it in PDM. So this standard cable would work. I see a preview here. This isn't bad. We could edit this part afterwards. But I'm gonna back out of this for a moment. Let's exit that sketch. We're gonna exit that route. This route is not happy that it took this long way around here. There we go. Okay, and then we're just gonna hide this second route. So this this standard cables is close. That got us pretty close, but when we want to revision manage it in PDM, that means it needs to actually be the same cable. It needs to actually be there in a physical library. This component, this option makes a new cable every time. It's faster. It's a faster way to do it than my first method, but it's still a new cable every time. So there is another function in routing called reuse route. That's almost exactly what I want to do, right? So if I do reuse route will let me pick from these different routes in this assembly. So maybe I'm going to reuse that one, or I'm just kind of picking through these so you guys can see what they do there. And finally, if I pick this route here, that's the exact copy of the first route that we made, the very first one. So if I hit green check on that one, it kind of follows the same approach. I'll drop that component, I'll drop that component, and then it auto routes from one point to another. So for this customer, let's exit that and we'll reopen that command so you can see what that looks like. This customer was pretty happy with that because not only could they reuse an existing route, but you could even browse to an existing route. So it doesn't even have to be a route that's in this assembly. It doesn't have to be here. You can browse and find it elsewhere, like for example, in a PDM vault, in a data management vault. So routing is pretty awesome. I would say if you do any type of electrical enclosures or pipe routing or anything like that, you definitely want to check out routing because it's it's something that can probably save you a lot of time if you spend a lot of time doing this. I actually did a YouTube video on this as well, a SOLIDWORKS routing tutorial that kind of goes into some more detail if you ever wanted to check that out. I think I had a link to this as well here. David, maybe what I'll do is I'll just drop this in the chat here. If anybody wants it at some point, you can certainly share it out or grab it. But same thing, just going into a little bit more detail of that route itself. I think I have like 100 views on that video, so I'm pretty famous if I've got 100 views on a YouTube video. Okay, so question number 3 here. And David, how am I doing for time? We probably have about 40 minutes left in my segment here, something like that, maybe 30 minutes.
Yes, we have 30 minutes.
Perfect, great. I'm still having my coffee. It's still 9 a.m. here where I am, so I still got to have a lot of coffee this morning. All right, this one's pretty interesting. I like this one because it's an old case, but it still came up time after time. I still got this call. Unwanted drawing references, even in PDM, and maybe you folks have seen something like this before. Even if I open up like this in this simple sheet metal box by itself, this is a really simple sheet metal enclosure, okay? And if I took this sheet metal enclosure and I did make drawing from part, maybe you've done this before where you take an existing open part and drag and drop just a plain old file onto it, something like that. Really simple. And let's see if we can get a sheet format on this. Got to have this look a little better than no sheet format at all. Let's just do like a landscape. Okay. So this is really simple, right? And you've probably done a drawing before, right? Where you just throw some models onto a drawing, you put your dimensions, and then you know, away you go. But the important thing about this is to understand that in file find references, the drawing references the part, right? That's actually the whole key thing with SolidWorks, is the drawing is actually referencing back to the part. So this utility, this find references utility, is interesting because it lets you check your links here, make sure that your files are connected to the right files and you're showing the right part here. And what's interesting is I only see the one reference. I see the drawing we just made. I didn't even save it yet, so it's saying file not found. And there's no other references. There's nothing else listed here. Right now, it's just that one single part, which is what we expect. That's what we want right now. So maybe I'll just save this drawing. I'll save it in downloads for today. That's fine. On the right side of the screen is something called the view palette. In the view palette is where we just were, you know, a moment ago. You can pick your existing views and drag and drop them onto the screen, right? If this view palette populates with another file, so maybe again we'll do, we'll just pick any other file here. Let me pick, we'll go into one of these existing files. This one's there. Where's this guy? Okay, so maybe something like in this folder here. So if I'm on this view palette, we will browse, and then I'm just going to paste this location in here. And it really doesn't matter what it is, right? It could be this whole enclosure. It could be any one of these other wires. This is, again, just an example here. But if I pick this enclosure at the top, the view palette will populate with previews of that whole enclosure, okay? I'm not actually going to use them though. I'm not going to pull any of them in. All I did was populate the view palette. Now, if I go back to File, Find References, once again, now look at the references list. And that's pretty shocking, because I know the only drawing that's, the only part that's actually on this drawing is this one. All of these other ones are simply there because of that view palette. That's very common. That was a very common call in tech support, is, hey, I opened up a drawing and I have all these incorrect references or all these extra references. And, you know, sometimes that's not a huge deal. You know, it's not necessarily a big problem. But if you're using SolidWorks PDM and you go to check in this drawing, you go to place this drawing into the vault, and all of a sudden that drawing tries to pull in 200 other files with it, and that's where you go, hey, something's wrong here. I need to check into this. So this view palette, if I jump back to the view palette, there is a way to fix this. If you have this enclosure picked and I hit this X for clear all, and I'll just rebuild this drawing, we'll go back to File, Find References. Now all those references are gone once again. So how does that happen? That's the big question, is how do you run into that scenario? It's common, maybe somebody there has done this before. Maybe you take a drawing and do a file save as, make a copy of the drawing and move it over and to use it as a template to start a new drawing. Then it may still have a view palette populated with old views. And that's hard to see. Like, you wouldn't even really notice that unless you were going to look for it. So long story short, if you're like this customer and you have unwanted drawing references, just clear the view palette. Go over and check out the view palette, make sure there's nothing in there you weren't expecting, and you can go ahead and clear those out. Okay, I like this one too. The question was, I'm having trouble creating one smooth face for an up to face end condition. So let's jump back to SolidWorks here. I'm going to use R for recent documents. I use this quite a bit. If you hit R, it'll give you your recent documents list. And we'll open up this sweep example. And this sweep example is, the question from the customer was not this file, right? I have to recreate this with sample files. This isn't the customer file, but they're taking a boss extrude and extruding it up to this sweep here, right? All the way up to this swept surface. And if I edit this feature here, it's a plain old swept sketch. There's nothing too complicated about it. It's 3 sketch lines. So we see 1 segment, 2 segment, and 3 segment sketch line that are being swept around a corner here. There's an interesting option though that I think a lot of people will miss. This merge tangent faces option is actually off by default. When you do a new sweep, this is off. So let's turn it off right now. I'll hit green check, and then we end up with 3 faces in here, 1, 2, and then a third on the outside. And that's okay. You know, for most cases, that might not be a huge concern to you. But with this customer, what they're doing is extruding a body like this up to that face, up to that swept body. And then what you end up with is 3 resultant faces on the bottom of this swept body. For 3D printing or manufacturing, other cases, you might not want 3 faces. You might want 1 smooth, continuous face there on the bottom of your swept body. So I'm going to use Shift Tab to bring that body back. I like that shortcut a lot. I use Tab to hide a body and Shift Tab to bring it back. I do that quite a bit. So that sweep, let's go back to that sweep, edit feature, and I will, in this case, turn merge tangent faces back on. I'll hit green check. Now you end up with 1 smooth face on the bottom of your extruded body. This is a simple example, right? This is a simplified example, but the customer had a very complex extrusion that was going up to a very complex swept face. So that merge tangent faces is an interesting option that, again, is off by default. So when you do a new sweep, that's off by default, and something you can certainly watch out for. Alrighty. Okay, so these next couple questions are kind of multi-part questions. And question number 1 is, why is my SolidWorks so slow? And that was a common tech support call, and that's very generic, right? That's tough to answer. Why is my SolidWorks so slow? Even after clearing the registry, updating my graphics card. If you've ever called into tech support before, those are usually the first 2 things that a tech support person would help you do: clear out your registry and update your graphics card. So why is my SolidWorks still so slow after doing those things, and why am I still seeing issues? So the answer in this case was the BIOS. If you're not familiar with the BIOS of your machine, it's actually like the underlying system that runs even before the operating system. So when you boot up your machine, when you boot up your whole computer, the BIOS actually boots up first, and it's something, if you want to, you can go into and make changes. My disclaimer here is check with your IT person. A lot of companies don't want you changing the BIOS. A lot of companies might actually prevent you from changing the BIOS, but that's my disclaimer, and proceed with caution, but there's some interesting things in there that you might want to know about. So item number 1 is something called Intel Speed Step. Intel Speed Step basically allows the computer to dial back processor power, turn down the processor speed if it detects a lower power state. So for me, and I actually ran into this on several computers. This is a Dell BIOS, but I know, and now I'm using Lenovo, and I know Lenovo has it and HP has it as well. This setting, let's say for me, I had a failing power supply. I had a power supply that was not delivering all of the necessary power. It was still working, but it wasn't actually delivering the correct amount of power. So Intel Speed Step was allowing it to turn down the processor on the computer. And really the intent of this is to save power, to save energy. If you're a SolidWorks user, you probably need all the power you can get. You want to have the machine running at high speed all the time, and you may not be worried about battery life or battery battery length. So turn this off. Intel Speed Step is something you can test with and turn it off. Some of these things are just troubleshooting methods. They're just troubleshooting ideas. They might not be a full-on solution to a problem you're having, but this is something easy enough to test, is turn this off. Another BIOS thing you'll want to know about is something called switchable graphics. The switchable graphics, a lot of computers, especially Dell machines, will ship with 2 graphics cards. They'll have an Intel kind of onboard integrated graphics card, a smaller graphics card, and then they'll probably have a separate NVIDIA card or an AMD card, a separate dedicated graphics card. This setting allows Windows to switch between those cards when desired. So for example, if you launch SolidWorks, if you launch a heavier program, it should switch to that heavier card and use that larger, higher end graphics card. Long story short, SolidWorks does not like that switching. SolidWorks does not handle that switching very well. So in a lot of cases, I would just disable this, enable switchable graphics. If you turn this off, you can force the machine to always use that higher end card, always use the bigger graphics card. And again, the intent here is to save energy. So if at all possible, the machine would try and use the smaller one, but use the bigger one when needed. I saw a lot of problems with that, though. I saw a lot of problems with it trying to switch between one card to the other. So again, this is a test. If you're seeing a graphics issue, if SolidWorks is slow, turn this off, see if it helps you. This is the third BIOS setting that's just kind of cool, and I think you should know about it. It's called USB Powershare. So this is off with Dell machines, but if you turn this on, it actually turns your computer into a big battery pack. You can take your laptop in your bag and plug your phone into it, and it will charge your phone even when your laptop's off. So it allows the laptop to kind of turn into a big USB power pack when needed. And I think that's kind of interesting. Again, this is off by default, but something kind of cool to know about that's kind of buried in the BIOS. Okay, that's all BIOS settings. Proceed with caution, check with your IT person on the BIOS settings, but really interesting things to know about. This next section, part 2, why is my SolidWorks still so slow, even after clearing the registry, updating my graphics card, and I did all of those things in the BIOS we just talked about. Why is SOLIDWORKS still so slow? And the answer in this case could be virtual memory depletion. And what does that mean exactly? So let's jump out to my task manager on my machine here. This is a live view of my task manager on my machine. And I'm going to focus in on the memory aspect. So in the memory aspect, my machine is telling me right now that I'm using 12.4 of 31.8 gigs. That's how much RAM I'm using right now. So you would think, hey, I have a lot of free RAM. That sounds like I'm only using about a third of what I actually have, or 39% utilization. There's more to this story. There's more to this memory story. So if I click on memory, we actually get a kind of a deeper breakdown as to what's going on here. And once you click on memory, if you look all the way towards the bottom, there's a separate utility called Resource Monitor. Resource Monitor is basically a more in-depth look at what's going on in the machine. So if I'm on memory and I see that same chart here, I see that same chart, but I see a very different story here. I see a very different story as to what's going on. I see that 12.5 or 12.7 that's being used. Here's that in use green section. But this blue section is something called standby. And free is almost nothing. Free for me, I'm basically out of free RAM right now. And I replicated this, by the way, by leaving my machine on for a couple days. And if you do this for 2 or 3 days, you could probably replicate the same thing. So the discrepancy here, the difference between this chart is basically saying, yeah, you're fine. You're only using 12 gigs of 32. But no, I have nothing. I have no RAM left. I almost have 0 RAM left. That's because of this whole category called standby. Standby is the same as this column here, commit. And if I zoom in, let's see what this says. It says commit is the amount of virtual memory reserved by the operating system for the process in kilobytes. So what that means is every time I launch a new program, every time we launch Chrome, we launch SolidWorks, we launch another program, it will dedicate a certain amount of RAM to that program and commit it and set it aside essentially. Well, at some point you run out. At some point you run out of that standby memory. And a lot of times in tech support, a customer will call in and say, no, I'm fine. I have a lot of free RAM left. I have a lot of free memory. Well, this chart, this little picture doesn't tell the full story. You need to take a closer look at how your machine is performing in terms of standby. So for me, I'm almost out completely of RAM, and I might now start seeing crashes in SolidWorks. The other program to mention here, I have a screenshot of it here, is RAM Map. This is a program directly from Microsoft. I'll just kind of open this up just so you guys can see what it looks like here. This is an actual live look at RAM Map. RAM Map is directly from Microsoft. It's from Cisternals, and it's a utility that actually allows you to, I'll drop this down. I'm not going to click this because I think it'll probably crash everything on my system, but empty standby list. This is a way you can actually purge that standby memory directly with a Microsoft tool. The other way you can do it is just reboot. Just reboot your machine, right? Reboot it and it should wipe that standby memory and you can kind of start over. But there is a concept of memory leaking, right? Where you've had programs open for so long, you eventually run out of free RAM. So the answer to this one, if SolidWorks is running slow and you're not sure, take a closer look at your memory. Take a closer look at your RAM utilization on your machine. Okay, so why is my SolidWorks so slow? Even after clearing the registry, updating my card, checking the RAM usage, checking the BIOS, I'm still seeing issues in SolidWorks, right? Well, then the answer might be, let's just take a closer look at the data itself. This is a pretty easy example. This is a pretty quick example we can show. This is an assembly with, you know, a bunch of parts in it, not you know, not 1,000 parts, but it's got a bunch of parts, a couple hundred individual parts here. There's a utility in SolidWorks that will help you evaluate this called assembly visualization. So when I turn that on, it will color code and sort your assembly based upon a value of your choosing. So for example, what's my heaviest part? Let me sort by heaviest. And I can see, oh yeah, that plate is the heaviest part in my assembly. That's useful. I can do that pretty quickly. But there's another button here at the top, the very top of this window. The fourth button in from the edge here will turn on a few new columns. So I'm zooming in so everybody can see this. But once I press this button, we're going to see a few new columns appear on the outside. So I'll turn on that performance mode, drag this out so we can get a little more room here. Total graphics triangles, SW open time, and SW rebuild time. Those are all very useful things to know, and they'll help you identify what's going on with your assembly, what in your assembly is making it slow. We've checked everything else. We've checked the RAM, we've checked the BIOS, we got the right card, we reinstalled a graphics card driver, we've done everything else. So it must be the data. It must be your SolidWorks file itself. So in this case, if I sort by total graphics triangles, I can see that these 6 guided injector pins are my heaviest files in terms of graphics triangles. They are the files that are weighing the most on my system. So if I pick those files, if you ever use this little shortcut before, component preview window, it'll open up a preview, an individual preview just on the right side, which is pretty useful. And I see those files, they're not terribly complex, but there's a lot of edges. There's a lot of individual edges. There's a lot of fillets on them, and there's 6 of them. So for everything that's wrong or every problem that you have, it's multiplied by 6. So that now is easily my worst offender in this file. This is an example, but on one of your files, it could be something with threads. If you've ever modeled something with a helix or threads, if you've ever modeled a lot of holes, a plate with a lot of holes on the top of a plate, that can quickly become one of your heaviest parts in terms of graphics triangles. So for a customer who's seeing slowness, who's seeing an issue with an assembly, my answer would be, well, let's suppress these files. Let's use this tool, find out what parts are the worst parts, and then suppress those parts and see if it gets better. It's a troubleshooting method. Again, it's not the answer or the end-all be-all solution, but it's a troubleshooting method for you to narrow it down and find out what is the worst file, what file is causing the bulk of your problem. So I would highly recommend this tool, assembly visualization. If you have an assembly that's just kind of running a little bit slower, assembly visualization is a really useful tool. Again, everybody has that. That's in every license of SolidWorks. This is a quick one. Why does SolidWorks RX say I haven't rebooted in several days? So this is kind of a funny one, but if I'm just gonna, on my other screen here, open up SolidWorks RX. RX is a diagnostics utility that you can open that installs directly with SolidWorks. Every install of SolidWorks will also install SolidWorks RX. And if you go to diagnostics, one of the things that diagnostics will do, mine are still refreshing right now. One of the things that diagnostics will do is it'll tell you when was your last reboot. So that section would be right down here. When was your last reboot? And I exaggerated this, right? 32 days. But that's it was common to connect to a customer's machine and see several days there. You know, if you're using SolidWorks every day, you probably want to reboot every day. You want to reboot and wipe everything and start over every day. As we saw before, you can lose that RAM. RAM can bleed out over a couple days, and all of a sudden you'll be left in a spot where you have no free RAM. So the question here is, why does RX say I haven't rebooted in several days? Even if you are rebooting, even if you are actually hitting shutdown, you might not actually be shutting down your machine. There's a setting in Windows called Quick Boot that even if you're hitting shut down, it doesn't actually shut down your machine. Believe it or not, to fully shut down your machine, you have to hold shift when shutting down. Hold shift actually does a complete shutdown on your machine and will clear out that memory, clear out everything. Next time you reboot, RX should actually show 0 days there. So watch out for that one. That's an interesting one. Okay, we probably got about 10 minutes left here, David, so I'll go through a couple more of these here. This is a sheet metal example. When I place a cut across a bend in a sheet metal file, how do I do that so the cuts look correct? Cuts placed in the flat do not show in the folded. Cuts placed before the flat are elongated in the folded. So this is an interesting little problem here. We'll jump back to SolidWorks just to show this sheet metal file here. Because the question, you know, if I'm a sheet metal person, I don't know if there's any sheet metal users there in the audience here, but if I'm a sheet metal user and I want to put a cut across a bent region, you know, and so now I go to flatten that part. Well, the bend, the cut ends up being kind of elongated, stretched out, and it doesn't look correct in the flat pattern. And if you do it after the flat, it's not going to show on the folded part. So there's a cool little feature. There's a cool little trick to know about sheet metal, and it's called unfold and fold. So unfold, if I choose unfold here, allows me to pick a fixed face, and I'm going to unfold this edge, and I'm going to hit green check to complete that. So it unfolded those two temporarily and flattened them out. So now if I do a sketch on this face and I do a cut across that bent area, it really doesn't matter what it could be, any cut, any example here, and I'm just doing a quick cut across that face just to show an example. Because this is sheet metal, you have these additional options to link to thickness and normal cut, because this is a sheet metal file, and I'll hit green check. That looks pretty good. I'm happy with that cut. So now I can return to sheet metal and fold. Fold lets you take what you did before. So if this is my fixed face and I want to fold that bend back up, fold that unfold and fold method are basically like a temporary way, a temporary option to unfold your part, add some features to it, and then fold it back up in the middle of a design process. That's really useful. So if you're anybody in the audience who's doing sheet metal design, you want to look for that unfold and fold options just as a way to temporarily flatten your part, temporarily unfold it, add a cut, and then fold it back up. So I like that one a lot. And sheet metal, again, sheet metal is a whole topic on itself, right? Sheet metal is pretty in depth by itself, but you definitely want to check into that one. All right, so for the sake of time, David, I'm going to finish with this one. This will be my last case here because this is probably one of the more interesting ones in this presentation. And again, for tech support, this is the kind of thing you would chase forever or have to look into for a very long time. So the question from the customer is, why won't my PDF files print correctly? That was the question. That was the phone call we get into tech support. So we'll go back to SolidWorks here. I'm going to do a window close all. We're going to wipe out everything I had open, get me back some of that RAM. I need a little bit more of that RAM right now. And we're going to open up a sensor enclosure here, which I think is this one. Similar, really similar file to before, but this is a different file. This is a little bit separate, a little bit different here. I'm going to take this same file and do what we did before, make drawing from part, and we're going to drop this file directly onto a drawing here. Okay, just letting this process for a second. All right, so we've got our drawing created. And if I took this drawing and then printed it, right? And maybe you've done that before where you've taken a SOLIDWORKS drawing and you've printed it to a PDF, and maybe you use that PDF as your company as the final file. So the question from the customer is, when we do this, when we print to a PDF, the view on the PDF is blurry. The view on the PDF does not look right. So where do you start? Do you start with Adobe? Do you start with the drawing? Do you go back to the model? Well, for me, I always try to work my way backwards. If you're seeing an issue with the PDF on this end, let's work our way backwards and find out where the problem is starting. So right away, when I look at this drawing, I can tell something's wrong with it. I can tell something's going on. This is the drawing that the customer would do: file, save as, PDF, and save this out to a PDF file that they would print, right? Maybe, and again, maybe this is something you've done before where you just take that PDF and save it out. I'll just do that in this example here. But even in looking at the drawing, I can tell something's up. I can tell something doesn't quite look right here, right? Let's open up that PDF we just saved. And the PDF looks pretty similar, right? I can tell on both sides here that the box itself doesn't appear to be coloring in. The box itself kind of looks washed out, and it's also not coloring in the box area. So I would again return to the drawing, find out what's going on at the drawing level. And my first indication when I hover over this view, maybe you can see next to my mouse there, but that little symbol with a lightning bolt is telling me this view is in draft quality. That little symbol with a lightning bolt means this drawing view is in draft quality mode. Draft quality in a drawing is SOLIDWORKS forcing it. It's forcing it into draft quality because it sees an issue with that view, and it's forcing draft quality to allow the view to calculate or to create. So you can click this view. I can click it, and if I just kind of scroll down here, maybe we'll switch to shaded. I can see even in the shaded view, it's forcing that view here to draft. It did that by default when it created. I didn't choose that, right? It went right to draft quality. Okay, so now I know something is going on with this file that's forcing these views into draft quality. And I've seen that before in tech support, and that usually means there's an issue here. There's actually an issue back here in the assembly that's forcing the drawing into draft quality and then forcing the PDF to not look correct. So there's a chain reaction there. And what you really want to look for in the assembly is what part is causing that problem. How do you narrow that down? How do you find out what part is causing that problem? The only real way to do it is start suppressing things. Start removing groups of parts. So maybe I would pick this entire board here. Maybe I'd pick the entire PCB assembly, the entire board, remove that, and then return back to the drawing and see if the problem went away. See if the problem went away. And then I could return back to the assembly and bring back a couple parts at a time until the problem comes back. That tells you, okay, I know I can narrow it down all the way until I find out what part it is. That takes a while though. Again, that is actually something that will take you quite a bit of time to narrow that down. There is a method for it. There is one quick troubleshooting method maybe that will show you that is pretty interesting. I'll show you here at the end. But all the way at the end, we found out it was this one diode, this one particular tiny part on the entire assembly. And maybe you can see in the audience already, but there's a missing face. There's a broken face on this file. And with a SOLIDWORKS file, you might run across broken geometry or an imported part, something that was modeled 20 years ago, right? You might come across that stuff from time to time. But this is, and I worked with this customer for a long time until we found this, this is the actual broken diode from that customer. I still keep it. I still use it to this day, because no matter what assembly I stick it in, it breaks that assembly. It immediately breaks that assembly and then breaks the drawing and then breaks the PDF. It's very interesting to see that chain reaction, right? And if you think about this question, why won't my PDF files print correctly? The answer was a needle in a haystack, trying to find that one tiny file that might be causing your issue. So my lesson here, or my recommendation for the audience is when you're troubleshooting something, try and work your way backwards in SOLIDWORKS. Try and work your way back to where the problem might be originating, rather than focusing on the problem itself. I could have stopped with the PDF, right? We could have troubleshotted at the PDF level and never actually found this broken diode. So for the customer, at the end of the day, all they really had to do was get rid of that diode in the assembly, and they were fine with that. Let's remove that diode, and then the rest of the assembly would open correctly. I'll show you this one last trick, and then we'll wrap up here with the presentation. I'll close everything. Once again, I'm gonna hit open here. And in this assembly folder here, broken diode, I'll expand this so we can see. If I pick that assembly option there, you've probably used this before, where you just open an assembly and it goes right to the default configuration. Well, underneath this configuration drop down, there's an advanced button. There's an advanced button that allows you to, on the fly, so I'll do that now, advanced, and we'll hit open. It brings up this additional menu where you can open the currently selected config, open the configuration showing all reference models, or a new configuration showing only the assembly structure, and you can give it a name. You can type in a name here. This is an interesting option. So if I do this, and we'll just call it test, my cap locks is on, test. It opens up the assembly, but it suppressed everything. Every single part in the tree here is suppressed. So now I can start unsuppressing one part at a time. Bring everything back one part at a time until that problem comes back, until you see that problem, until those drawing views go to draft quality all of a sudden. So that's how you would walk this problem back, is you do this one step at a time and try and find out the problem that's causing, the part that's causing all your problems. All right, so David, I had a couple others there for you, but I think for the sake of time, we'll stop there. I want to say again, thank you for having me on. I appreciate it. And if anybody does have any cases, please send them to me. Please email me. I'd love to chat about them with you.
Thank you, Dan. Thank you that you have a time and joined to us today. And I know you now will have another meeting, so you. Thank you.
Yeah, thank you, everybody. Thank you so much. Nice to meet you, and thanks for your time. Have a great day.
Bye. So now we have a coffee break.